In this video I'm going to assemble the crankshaft components. So now we've got all the parts for the crankshaft finished, ready for assembly. Off camera I've gone and made all the various shafts. So this pin here goes in the top of the crank webs. And we've got a spacer here which goes in between, and this is where the connecting rod from the piston connects to. So because this would be quite difficult to lubricate on the engine because it's underneath the boiler, I've decided to make a cast iron bush, because I think cast iron will be a better bearing material should any lubrication break down, rather than the stainless steel. So that will get Loctite onto there. I've got a couple of bushes here. These are temporary bushes that will go between the webs to provide a measure for the gap between the webs, and also some rigidity for when I put this in the lathe to do some turning between centres to get the ends of the shafts to the correct diameters and in line. So as we assemble the parts, I'll clean them with alcohol to degrease them as best as possible and use some Loctite. However, I have made these a light press fit. One of the problems we might have is, because these are all the same grade of stainless steel, there could be a galling problem. That's quite common with stainless steel components. I'm not sure how 431 behaves as regards galling, but anyway, if we put the Loctite in, hopefully that will add something to the strength, but also add something to preventing galling. We'll just have to wait and see. So I think we're ready to assemble our first shaft to our first web. So we need to get this web on here at 90 degrees. So I'm going to use my 1, 2, 3 blocks, stick that on there. I've actually made this with a little bit of a lead in so I can position it. So we'll put a bit of Loctite on. Okay, put that on there. And the other 1, 2, 3 block up against it. Okay, we should be nice and square. Try and keep it at that orientation. Okay, we'll just check it and see what we're like. That looks perfect. Can't detect any play. Looks good. So I'm just going to fit these little spacers on now. Okay, so I made these pins more of a close sliding fit, which should be good for the Loctite. Well, I'm putting a pin in anyway, so should be okay, I hope. So I've degreased these, so I'm wearing a glove because I don't want to put any of my fingerprints on it. And I wanted to just come proud of the surface at the back, just ever so slightly. Okay, we can put on a little cast iron sleeve. Make sure it's firmly seated. I'll let that set. Okay, it's ready for the final bit of assembly. So we can put some Loctite on here. Okay, now we need to just knock that in together. Okay, so I'm going to put some pins in these joints. We could put them in across through the web that way, but instead I'm going to put them in from the end. And I've got some 4mm bar, and this bar actually measures 3.99 millimeters, which is very close to 5/32. So if I take 3.99 minus 5/32 times 25.4, it gives an interference fit of 0.02 millimeters, which is ideal. So that's pretty convenient. So we're going to drill and ream these holes. I've already got them marked out on these two webs anyway. Going to drill and ream them 5/32, and we're going to push in this 4mm bar, and I think that should be plenty strong enough. So I've cut 2 pins. I'm just going to file it flat along one side to allow air to escape when I press it in. Okay, I've got some alcohol here, and I've got a pipe cleaner. Dip that in there, and just give these holes a clean out. So I've got it set up in the shape of ice. So I'm going to be a little unkind to my shaping machine. I'm going to be hammering these pins in. I'm going to apply a little bit of Loctite. I doubt if it actually does anything or adds anything to the strength of the joint, but it'll give a bit of lubrication to stop any possible galling of the stainless steel, hopefully. It can't do any harm. There we go. It's good. Should be a nice tight fit. Okay, so I'll just do the other ones exactly the same. So I'll do these two here, and I'll do the other ends as well. And then it'll be ready to go in the lathe for turning. Okay, so I've got it mounted in the chuck to see how straight it is. The chuck does have a bit of run out though, usually 3 to 4 thou. So that seems to be the low point there. So it's 0.1, 0.2, 0.3. So it's like 12 thou. So it's like 0.15 offset from the centre. So it's like 6 thou, so it's 6 thou eccentric on the end there, which I think is not too bad really. I think we can live with that, no problem. Going along the length, that's about, well, it jumps when I change direction, so that's pretty straight actually within say 0.2. Try a different place. It's a bit further out. 0.4. Try it there. That's perfectly straight, so no, I think I'm quite happy with that. But it's got to be turned between centres, and that will keep both ends running true for the bearings. So I've got this space in between the two webs. The idea being is that when I put it between centres, we're going to apply an axial force which is going to compress it along its length. So these spaces will take that load and nothing will deflect, hopefully. Not to any great extent anyway. And then once we've finished machining the ends, we can cut these spaces out and hopefully nothing will move. So that's the plan. But you know how to make God laugh, don't you? Tell him your plans. Over the last week this channel has exceeded 1,000 subscribers. Thanks to everyone who has subscribed, it's very much appreciated. If you've enjoyed this video, please like and share. Thanks for watching. See you next time.